So today we're going to be taking a look here at section 8.3 on it's an introduction to normal distributions. And so we need to understand, well, what does that mean? So you can see that it starts with here, a normal curve is a smooth curve that is symmetric and bell-shaped, right? AKA mound shape, like it has a mound to it. So you can see the mound, right? Data distributions that are mound shape are often modeled using normal curve. And we say that such a distribution is approximately normal. One example of a distribution that is approximately normal is the distribution of Compy heights. Remember that was the dinosaur, right? From our notes in section 8.1. Shown to the right, that's this information here. If we draw a smooth curve on top of the histogram to approximate the shape, it can be easier to see. Okay, so we're going to take a look at this. And, sorry. It says here, draw a smooth curve connecting the midpoints of the top of each bar in the histogram. So I'm going to do that first. So I'll just go in, and at the top, there's a histogram, right, which shows your relative frequency as percents here. And at the midpoint, at the top of each of these, I'll just draw a little dot. Okay. So there we go. Midpoint of each of them looks something like this. And if I connect those dots, it should look something like this here. And then come back down. And we get something like that. Okay, so what are some characteristics of this curve? Whoops, sorry. What are some characteristics that we see in this curve? Well, I think that you can see that there's a sense of, it's symmetric, right? There's symmetry, right, about the middle or the peak, right? You see it's on both sides. It has, so I'm going to write here symmetric. So it has the one peak, right? It comes up to the peak and then comes back down. And then the last one, you can see that it tapers at the edges, meaning that it just gets less and less and less, right? Has this great fall, right? Steep fall, and then it tapers at the edges. Okay, so let's just take a quick peek here at the next section. It says, for each of the following distributions, indicate if it is approximately normal, skewed, or neither. What do you think about this first one, A? What's up? This one here. Does it look like it's approximately normal? Does it feel like it's skewed left or skewed right, or neither? Okay, I hear approximately normal. How about B? It looks like it's skewed, doesn't it? Okay, is it skewed left or skewed right? Yeah, remember, it goes up to its peak quickly and then tapers off on the right, right? It's getting pulled off to the right, so this is skewed right. How about C? What does this one look like? Goes up, comes back down. What would you guys say for that one? What was that? Looks approximately normal. How about D? Yeah, it doesn't look like it's either skewed or approximately normal. So all right here, neither. All right, and then finally E, they have this huge graph, right, or grid line, and this little itty bitty graph on there. What does this one look? Yeah, I'd say approximately normal. Are we good with that? All right, let's move on to the next one. Okay, gas mileage and normal distributions. It says here, a salesman kept track of gas mileage for his car over a 25-week span. So it says using technology, so then it gives all these gas mileages, right, per week, and it's for 25 weeks, so there should be 25 numbers there. Using technology, he found the mean and standard deviation of the mileage data. So the mean was 26 and 400ths, and here you got that 1.457 for the standard deviation. It says here, calculate the frequency of each of the mileage values. Put those values in the second column of the table to the right. Well, we can do that. How many 23s do we see? Right? Well, there's a 23 here. I'll cross off as I go just so that I can keep track of what I've already got. I have 123 and that's all I see. So I have 123. And then how many 24s? Let's see here. I saw one in the bottom row. So there's one there. And then we have 2, 3, and that looks like that. 25s. Well, let's do the same thing here. 25s. We have none in the bottom row. So I have 1, 2, 3, 4. 26s, they're already there. I'll verify that there's 2 in the bottom row. 1, 2. And then 3, 4, 5, 6, 7, 8. And there were 8, so that's good. 27, let's see, there's one in the bottom row that finishes off the bottom row. 1, 2, 3, 4, 5. 28, let's see, we're just looking at this row now. So there's 1, 2, 3, and then 29s. I see 1, 1. That finishes the list, doesn't it? If we're just looking at the numbers, do they start small, go to a peak, and then come back down? Yeah. Notice here, right, the total that they have here, right, that's because they added all of the numbers that were given, right? There's 25 numbers. So it looks like it might be approximately normal, but probably having a graph would be good to look at. In 4, it says calculate the relative frequency of each of the mileage values. Put those values in the third column of the table. Remember that relative frequency is the proportion in that category. It can be found by dividing the frequency by the total. So literally, you're just going to take 1 and divide it by 25, and then 3 divided by 25, right? So I'll write here just for the sake of, this is 1/25th. And when you divide that, that's 0.04. So this one's going to be 3/25, which is 0.12. It's telling the percent of those numbers in the list. Does that make sense? So there was 4% of the numbers that were 23. There were 12% of the numbers were 24. Does that make sense? Okay. This is going to be 4/25, which is 0.16. This one's going to be 8/25, which is 0.32. This one's going to be 5/25. That's 0.20. This is 3/25, 0.12. This is 1/25, which is 0.04. When we get to the total down here, what do you think those are all going to add up to? Yeah, because it should be 100%, right? 100% of the data is represented here. And when you do add those up, which would be 1 as a decimal, right? So 1.00. Okay, and then it says construct a relative frequency histogram using the grid below. So relative frequency, right? So we're going to see those percents listed over here. And so we can do that. So here's 23. I think I'm just going to help my eyes. I'm just going to draw a tick mark kind of halfway between the numbers to guide my. Okay. So here's my first one. We know that for 23, if I look up here, oh, you didn't see what I did. I just drew these like little dots here, tick marks to help me. 23 was 0.04. So you can see 0.04 is right here. And I'm going to just we're drawing a histogram, so it's going to be these bars. I think probably just to make it a little better here, I'm going to draw in this grid line here. I think that's fine. Okay, so we have that one. And then the next one is 0.12 for 24, it's 0.12. So 0.12 looks like it's going to go about here. $25, that's 16%. So looks like it's going to go something like here. Ugh, sorry, off just a little. It's okay though. Let's see, 26 is the highest frequency. That's 0.32. It's going to be all the way up here. Let's just draw. I'll try and. $27, that was 20%. That's 0.2 right here. $28 was 12%. And then 29 was that 0.04. Okay, now just looking at just the general shape, is it looking like it's normal? Yeah? Okay. Let's bump that up a little bit. Do you expect the median to be greater than, less than, or about the same as the mean, and why? Oh, that's a good graph. Do you guys remember? We learned this in our lesson earlier, previous lesson. Do you see, is the graph symmetric? Yeah. So since the graph is symmetric, then we would expect the mean and the median to be approximately the same, right? So I'll write here, since the graph is symmetric, the mean and the median should be approximately equal. Let's do this here. The next part here says, describe the shape of the mileage distribution. So I would describe the shape as being symmetric. You can see that it has one peak. Would you all agree? And does it look like it's tapering at the edges? I'd say that. So I'll just put here, therefore, it looks approximately normal. Then it says, draw a smooth curve that comes reasonably close to passing through the midpoints of the tops of the bars of the histogram. Is this approximately normal curve? Well, I think without even doing that, we're going to say yes, right? It does look approximately normal. But let's actually draw that in. Okay, so I have to take this off. I'll put it back up here in just a minute. And so if I put the midpoints, right, of the tops here and connect them, right, it looks something like this, right? Not necessarily going through all of them, right? Goes up, back down. Do you get the idea? They didn't say it had to go through, but it close to it, right? Then it says, use the table and histogram to answer the questions below. Okay, so I'm going to go ahead and come down here. Okay, it says, Find the proportion of the data with one standard deviation within one standard deviation of the mean. Okay, so in order to find one standard deviation of the mean, you're going to do the mean minus 1 SD, right? SD, standard deviation. Are we okay with that? Yeah. Okay. So, if you remember correctly, they told us up here that the mean was 26.04 and the standard deviation was 1.457. So the mean, right, that's going to be 26.04. And then it's 1 times the standard deviation, which is 1.457. So obviously 26.04 minus 1.457. And isn't that just going to be 24.583? Are you okay if I just do the arithmetic? You can hardly see that. Let me bump that up a little bit here. So the mean plus 1 standard deviation would be the 26.04 plus 1 times that 1.457. So that's going to be 26.04 plus 1.457. And when you add those together, you're going to get 27.497. So the interval, right, would go from the low, which is the 24.583, and it would go up to the 27.497. Now, if we round that, it's going to go, that rounds to 25. This one rounds to 27. The proportion of the data, well, we're going to have to go to our bar graph. So let me go to my bar graph. Okay, I'll put this back up, but let me go to the bar graph here. Okay, and we said that it goes from 25 to 27. I'll just use the rounded data here. So 25 would be here. I'll just draw. And then 27 would be right here. Okay, and I'll say this is X, right, the average minus 1 standard deviation, and this is the average plus 1 standard deviation, right? And maybe we should put the average on the graph. Let me do that. I'll do it in green just so we can see it. The average was 26.04. So I'll just kind of draw it in here. Maybe it should be further to the left, but I'll just do here average. Okay, how are we doing? Are we good? So they're asking what percent of the data is in here, right? Is that our proportion of the data? So we can look at the heights and get it that way, right? How high did it go? This was 0.16. This was 0.32. This was 0.20, right? Or we could pull it from the chart for 25, 26, and 27. 0.16, 0.32, 0.20. Do you guys see it? Okay, so let me put this here. So I will do here 0.16 plus 0.32 plus the 0.20. So you can see that this is 0.68. And it turns out that in one standard deviation, if you go out 1 standard deviation from the mean in both directions, that it's about 68% of the data needs to be between them if it's a normal curve. So this is looking pretty good, isn't it? Okay, are we good with the first one? Can we go to the second one? Now it says find the proportion of the data within 2 standard deviations. So this is going out 1 in both directions. Now we're going to go out another standard deviation in both directions. Okay? So 2 standard deviations from the mean. So in order to calculate that, right, we're going to take the mean, which is the 26.04, and you're going to multiply minus 2 times that 1.457. So this is going to be 26.04 plus 2 times the 1.457. So 2 times this, so this gives me 26.04 minus 2.914. So this is going to be 26.04 plus 2.914. And then when I subtract these, you get 23.126. And when you add them, you're going to get 28.954. So the interval will go from the 23.126 all the way up to the 28.954. If I round those, that's going to go from 23 to 29. Are we okay with that? Yeah? Okay. So if I look here, right, 23 to 29. Well, here's 23, here's 29. So I can So this is X bar minus 2 standard deviations. This is going to be X bar plus 2 standard deviations. Well, notice now I have to take the middle part, right? And I have to add the 23 and the 24's proportion to the middle part and then add 28 and 29's. Do you see that? So, here. So 23 is the 0.04. 24 is the 0.12 plus, and then I have to add the next 3, right? That's these 3 right here. But didn't I do it right here? So I'll just 0.68. Okay, and that covered to here, and then I have to do 28 and 29, which is the 0.12, and the 0.04. When I add those together, I'm going to get 1.00. We get it's 100% of the data at this point, right? In the data that we have here, right? Now sometimes we'll even go a third standard deviation out, and so you can see that that's what we do in this last section. So that would be the mean, which is the 26.04 minus 3 standard deviations. So 3 times that 1.457. So this will be 26.04 plus 3 standard deviations, 1.457. So get my calculator, and when I multiply 3 times 1.457, I'm going to get 4.371. So this is going to be 26.04 plus that 4.371. So when I subtract the two numbers here, I get 21.669. And when I add the numbers, I get 30.411. So my interval here is 21.669 to 30.411. And then this goes from, right, if I round those intervals, that'll be 22 to 30. Well, if I come here and go from 22 to 30, 22 and 30 aren't even on my graph, are they? So I'll just, for the sake of just putting it on here, this is x, right, minus 3 standard deviations. And then I would have one over here. This would be x bar plus 3 standard deviations. But there's nothing to add, is there? We already have 100% of the data taken within 2 standard deviations. Do you see that? So all I'm going to do for this last one here then, where it says what proportion of the data falls between it, you're just going to bring down this one, and there's nothing to add to either side. Okay. Are we good with that? Yeah? Okay. Let's take a look at the lesson summary. Normally, it's not new information, so it's just good to review it, but there is a little bit of new information in here, so I want to just make sure we take a minute and look over it. So it says, in the activity and in the examples, we identified what approximately normal distributions look like and started investigating how they behave. Specifically, we estimated the proportion of values within 1, 2, and 3 standard deviations of the mean. Because those distributions were approximately normal, the answers varied a bit among the examples. Nevertheless, okay, and we only did one example, by the way. If a distribution is approximately normal, we can use a perfect normal curve to model the situation and give reasonable estimates about percentages and probabilities. We will use these percentages for another purpose, determining whether a given distribution is approximately normal, and therefore whether a normal distribution can be used to make predictions for that distribution. The other method for determining whether a distribution is approximately normal is to sketch a graph of the distribution. As we see in well, we didn't do exercise 6, so but as we saw in what we did, right, determine whether it appears to be symmetric or mound-shaped. Normal distributions are symmetric, mound-shaped distributions. One method for determining whether a given distribution is approximately normal is to sketch the graph. A second method is to calculate the percent of data within 1, 2, and 3 deviations of the mean. And so then you can see here, right, they have this is a generic, right, normal distribution, right, where 0 would be the mean, right, here. So then going left and right to the -1 and 1, that would be going out one distribution from the mean. Actually, it looks funny to me, so I'm going to redo this here. I'll just write it this way. So, and this is going out one distribution in each direction. I'll say one SD. Is that okay? One standard deviation, sorry. Notice that one standard deviation is 68% of the data. Do you see that? So about 2/3 of the data you can think of, it falls between one standard deviation. Notice that if I go out from here, right, to the 2s, right, that's going out 2 standard deviations. And you can see that 95% of the data will fall in between there. In the example that we did, it ended up being 100% by the time we rounded. And then finally, right, if we go out 3 standard deviations, you can see that you should have 99.7% of the data. So that 0.3%, those are going to be the outliers, the things that kind of fall outside of the data. Are there any questions? So with that, we'll end the lesson.